Hello, and welcome to another episode of Microgravity Mischief. In today's episode, I'll be talking about the future of the Artemis project on the moon. So join me on a Kerbal Space Program future mission to the Shackleton crater on the south pole of the moon. What you're watching now is the launch of a future Starship to ferry astronauts to the moon base. And what I'd like to talk about during this episode is the details of what it might take to establish a permanent moon base. As we all watch SpaceX from the sidelines building their new Starship system with huge hopes for the future and moon bases and Mars colonies, one of the things that we don't often talk about because there's no money being spent on it right now is the infrastructure and how to develop it. And there's a big difference between doing it on the moon, doing it on Mars, and the pilgrims sailing over from Europe to America to colonize the New World. One of the benefits that they had back then is that they operated in a breathable atmosphere on Earth where all the natural resources were abundant. And when we go to the moon or we go to Mars, we're going to need replaceable parts, and we're going to need to bring them in bulk because we won't initially have the foundation we need in such buildings as a foundry or a forge. We won't be able to create threaded fasteners until we get CNC machines up there. And we don't want to carry all those base materials with us. Initially we'll have to, but eventually we're going to want to mine the lunar surface regolith for iron ore, aluminum, titanium. There's lots and lots of it. There's rare earth metals there. There's helium-3, there's nitrogen, carbon dioxide, oxygen, helium, hydrogen. Everything we need is there. It's just more in a base form. It's more of an elemental form of everything, which requires much more processing to get the end result. So now as we circularize the orbit, we're going to continue on with a refueling mission where another Starship will come up and dock with our existing ship and transfer the fuel and then deorbit back to Earth for its next mission, and we will continue on to the moon. So I'd like to share my insight with all of you folks about the non-destructive testing world and how it applies to everything that we're going to be seeing in the future of Artemis and Elon's colonization of Mars is non-destructive testing of metals. And so what this really is, instead of doing a bend test or a break test to see what the tensile strength is of, a bar of a bar of steel or aluminum or any sort of material that we're using, we want to look at it with ultrasound or x-rays or liquid penetrant, where you simply add a dye penetrant to the surface and then wipe it off, and because of capillary action, dye penetrant will circulate into cracks or discontinuities within the material, and then you spray a developer on it, which will draw it out of the crack, and you can see imperfections in your materials with the naked eye that you wouldn't be able to see without a microscope. So it's a very efficient way to look at the structural integrity of things that we want to use for our day-to-day operations, whether they're life support or things to just do work on the moon with. And so we've got to understand that the amount of life support systems and habitation modules is one thing, but we're also going to have to create foundries and forges and machining complexes where we can machine a steel bar stock into a threaded fastener. And so this opens up a very large can of worms, as there's going to be many different companies fulfilling contracts for NASA, and unless NASA can keep a tight cap on everything and force these companies to standardize as much as possible with each other so that you can interchange threaded fasteners and parts, well, maybe not parts as much, but definitely threaded fasteners. You don't want to have to take a bin of 5,000 of every conceivable threaded fastener to the moon just in case a critical threaded fastener fails and we need to replace it, you just can't carry that much to the moon. The cost would be astronomical and it would shut down the mission. So one of the things they're going to have to do is set this all up on the moon. So almost on a weekly basis while I'm playing Kerbal Space Program, this content creeps into my mind and I start thinking about what it might take. And one of the things that I always kind of fall back to is an interview that Everyday Astronaut did with Elon Musk, in which Elon outlines that prototypes are easy and production is hard. And so I always apply that to things when I think about the moon and a future moon base. Do we want to take an existing bulldozer or backhoe, for that matter, to the moon? Do we want to retool it and turn $500,000, well, maybe $100,000 or $200,000 machine into a $2 million machine just to make it more specific to the mission? Or can we just take an existing backhoe, increase the length of the arms, the hydraulic arms, and the size of the bucket, and put it into operation? And will it work okay? Will the grease fittings have a problem in the very low temperatures in the shade on the moon? Will they need to retool that? All of these things need to be explored. I'm sure NASA has explored quite a bit of it, but in any case, there's a lot that we have to consider. Well, it looks like we've completed our retro burn of the refueler and it's getting ready to re-enter the atmosphere. Now we're going to conduct our transfer burn out to the moon. I could have gone a lot more into detail with the maneuver node and oriented it so that when it arrived at the moon it wasn't on a collision course, but sometimes it's just easier when you have all this extra fuel just to do it the easy way. So that's the way I did it. So here we are, burning away, increasing our velocity, raising our apoapsis so that we get a moon encounter. Clearly we have lots and lots of problems to solve and figure out as we get closer and closer to the future of this mission. How are they going to support electricity and power? If they're in the shade, are they going to set up solar panels on the edge of the crater? If so, will those solar panels be enough to generate all the power you need to get the whole thing going? Are they going to eventually build some sort of nuclear reactor, which would be a hassle because you wouldn't have a lot of extra water sitting around for secondary coolant and tertiary coolant. Just, you have to have redundancies in those systems so you don't have nuclear meltdowns. If Elon Musk can really get the cost of flying a single Starship to orbit to $1 million or $1.2 million, whatever he talked about, and I believe Everyday Astronaut quoted that it would take 8 to 10 refueling ships to completely refuel the lunar Starship, which at $8 million a pop is still 100 times cheaper than what we're doing it for right now. It's going to open up all kinds of opportunities. And if you specially design the lunar ship to be a cargo ship to ferry goods and materials and equipment out to the moon, to the colony, you can really take a whole bunch out there in very short order, which I think obviously is what we'd need to get a good start on it. I think it's time that we start thinking bigger. Do we want to make these small, tiny little isolationist habitation pods that we're going to live and work out of, or do we want to think bigger from the get-go? If we can really move that much tonnage to the moon for that low a cost, we need to start thinking about fabricating industrial buildings that are pressurized out of plate steel or aluminum. A naval Trident nuclear submarine weighs about 18,750 tons, and if Starship has a useful payload to LEO of 100 tons, and it's fully refuelable so that it then can travel out and land on the moon and deliver that payload, you're looking at 187 trips. And if it takes 10 refueling tugs to refuel each Starship before it heads to the moon, you're looking at 1,870 flights of Starship. And if you multiply 1,875 flights times 2 million, let's go a little bit on the conservative side and say it's going to cost more than $1 million per flight. Let's double that. You're looking at a grand total of $3.75 billion to cut up a naval nuclear Trident submarine and transport it to the moon. So because the pressure hull of those submarines is so thick, and we don't need that thickness as we're not dealing with those immense underwater pressures, we can reduce the thickness of the plate that we're transporting greatly. I don't know, maybe say a 1/4 inch, maybe 3/8 of an inch, maybe a 1/2 inch thick plate to be on the safe side. maybe that's altogether too thick, but the idea here is longevity and the day-to-day maintenance that'll go into maintaining the structural integrity of these buildings. I personally, if the cost of spaceflight is that low, believe that it would be beneficial to start with a material that's much thicker than you need, so that as you work it over the 40, 50 plus years to maintain its integrity as it degrades over time. Sometimes you find where a crack starts, and so you have to excavate it and re-weld it, and over time there's a little bit of corrosion, so you sand that away. You basically want to start with a thicker material than you think you're going to need. I think that you'd have to probably use corrosion resistant steel, stainless steel, or as they call it, I think Starship is using the 304 series Cress. Maybe you could use 404 series, and that way you'd be able to do magnetic particle testing to all the welds to look for surface connected cracks that are beginning, so that we can repair them before they start. And Cress happens to be terrible for ultrasound inspections, but you can x-ray it very easily. But the give and take with that is that it's harder for an x-ray to see a crack. They do find them, but lack of fusion and cracks tend to confuse an x-ray technician more than it does an ultrasound technician. And the problem with Cress is that you really can't use ultrasound on Cress. It just doesn't give you a good picture. The grain boundaries of the steel itself steer the sound down to the root of the weld, and you never really penetrate the actual weld itself, so you don't get a decent inspection. You really don't get full coverage, but with an x-ray you can get very good coverage, and you can basically certify the material. So basically, in the end, what I'm talking about here is building an industrial sized building for about $3 billion on the moon. And once you get, a foundry, a forge, and a tool and die building going on the moon, and you start a mining operation where you can take the raw regolith of the moon and turn it into an end product like a threaded fastener or a valve. You can cast a valve body and basically create every part that you're going to need to sustain yourself and to grow. Once you hit that tipping point, who knows what the possibilities are going to be. I'd love to see a golf course on the moon where your average drive is about 3,000 feet or 3,000 yards. Excuse me. That would be one heck of a golf game. I'd love to see a supercross race on the moon on a huge domed building where, these guys are jumping 200 feet up in the air and traveling, and it's just slow. Imagine how many backflips they can do. I don't know what percentage of what I'm telling you guys is probably going to be useful. I think that I'm looking at it from a biased point of view, from a submarine and aircraft carrier non-destructive testing technician. And I know that it's a lot different than the aerospace industry. And so I'm making a lot of logic leaps here. But I think the underlying information that I'm conveying is pretty sound. It just maybe some of the details might be a little bit different. So correct me if I'm wrong. Feel free to correct in the comments. I do suspect this about myself. It would be very difficult to motivate me to work hard if I was in the space industry, unless I was a really big part of it, because zero gravity is such a fun plaything for me that I would probably end up following it around like people follow the Grateful Dead concerts if I had Elon Musk's kind of money. I don't think I'd be motivated enough to take a risk and start my own company. So it's pretty difficult to speculate about how things are actually going to turn out with the space station, what designs are going to be adopted fully and implemented. So whenever you see a video, or whenever I see a video about Artemis and what the space station is going to look like, I kind of take it with a grain of salt, as I think you guys should here. I just basically putting something in orbit that has habitation space and some fuel tanks, the ability to generate power and communicate with Earth. I think that the near rectilineal halo orbit that they're going to put it in is a good idea. I think it's either once a month or twice a month. It's going to have a very good position to conserve fuel and actually conduct a burn that's going to get you home. As they're already in a very elliptical orbit, you don't need much fuel to do so. And really, in effect, if you think about it this way, it's kind of like you've got a trip to take with your automobile, your car, and it basically is going to take 2 tanks of gas to get there. So you want to put the gas station at the exact halfway point. So you haven't tightened up your lunar orbit and circularized it. You've still left one half of your orbit in a huge ellipse. So you're kind of on the cusp of falling out of orbit with the moon and back into orbit with Earth. So it kind of mathematically, and from a standpoint of delta V, is kind of a halfway point. I think that's why they put it there. For emergency purposes or whatever, the people from the space station or habitation module, they can jump in a ship and head back to Earth with very low cost of fuel. And so it's probably going to be a kind of a halfway fuel depot as well. Although, I mean, how much liquid oxygen and liquid methane or whatever fuel you're using do you want to be sitting on top of in a space station? Maybe they'll have a separate station orbiting that's really just a big fuel tanker, because they don't want people sitting on millions of tons of explosives. So here we're following the orbit, speeding up the motion so we can see what it's going to look like over time, and then we're going to speed up what it looks like from a first-person point of view. See that moon zips by at your perigee, at your lowest point, you're traveling your fastest, and I imagine it'd be quite a view to behold. So I might be out to lunch here, but I imagine that with the sheer size that Starship is, they might break up some of their missions to half cargo, half personnel, or maybe they'll separate the two of them completely. What I did in this mission is I just figured that maybe in the early days, landing a Starship every time and leaving it there permanently would definitely be a good idea for habitation purposes. I ended that by emphasizing a syllable. It made me sound like I was asking a question, but I'm fairly confident that it's really a great way to live during the early days. However, ferrying people to and from the moon might be more efficient in a smaller ship, as you're just not hauling around that much weight. I mean, it would be like sort of driving a semi down to McDonald's to get your lunch every day from your workplace, as opposed to like jumping on a motorcycle or getting in a Tesla Model 3 like I enjoy driving. Yeah, the Model 3 Performance is quite a vehicle. It's faster than my Ducati Monster 1200S. It's technically not faster, but it's faster for me because I can't seem to keep the front wheel of the motorcycle on the ground long enough to keep accelerating at the rate that motorcycle can actually accelerate at. Furthermore, that motorcycle shifts out of first gear at 40 miles an hour, unlike most of the rice burner motorcycles like Honda and Yamaha. They'll take you up to 80, 100 miles an hour in first gear. So that a few hundredths or a few tenths of a second where you're shifting from first to second, that is where the Tesla Model 3 Performance just zips right by me. And so I think this year I'm going to go ahead and sell my motorcycle, and I'm going to use the money to buy a really awesome personal computer so that I can make really big bases with Kerbal Space Program 2. I don't quite know, and this is speculation as well, how well the game's going to perform in colonization mode, because right now in Kerbal 1 we all know that the part count makes your processor slow down dramatically, and you get cracking issues, you get lag issues and stuff like that. So I'm curious to see when the new game comes out. I think one of the first things I'm going to do is test it out by building gigantic rockets with lots and lots of parts to see how much it bogs down my computer, and then we can watch over time. Hopefully they address that issue and it gets better, because if we truly are going to get into a colonization phase in this game, which would be incredibly awesome and so much fun, they really need to solve the problem of the part count, because colonies are going to take thousands and thousands of parts. So I'm not a computer programmer, but I know from making videos that when you splice video clips on top of each other and do window and window stuff, it takes a lot of GPU. And so when you then render the video, it turns it all into one film clip, so it's not struggling so hard. So maybe if that's how they're programming it, maybe when you're in the vehicle assembly building, it would be possible for them to, once you complete your spaceship, you just hit a button that will render it into like maybe three functional parts, so that the PC that is doing all the work to fly you around only has to deal with 3 parts as opposed to 200. And if we had to wait an extra minute or two while it reconfigured or rendered the spaceship you built into a few pieces, it might turn out to be a great idea. But like I said, I'm not a programmer, so I'm sure that some of you out there, maybe especially the modders, if you see this video and listen to this part of the commentary, you probably have a way better idea than I do. All I know is that I'm very hopeful that this game is going to be just epic, and that I'm going to want to play it instead of going on vacation. So all you Kerbalnauts out there that are watching me take this smaller ship in for a landing at our Shackleton Crater Base, you'll notice that I forgot to set the landing pad as my target. So on my nav ball, I don't have the guidance to really aim quite as well. And it wasn't until after I flew this mission that I realized that it sure would have saved me a lot of time. And you'll notice as I fumble around here and kind of screw it up and have to climb an altitude back up to realign myself before I can come down and make a nice soft landing on the landing pad, that I really ended up doing this the hard way. But luckily for me, I overspec'd the lunar lander ship that I created here so that you have some room for error to make up for lax of judgment like I made. And so at the base here, we've got a landed starship, we've got a tank farm that I built and brought out here, and a big landing pad that I built and brought out here, and I used sort of a simple design of landing thrusters to just go ahead and place everything on the moon. And I didn't really want to take you guys through all that, otherwise this has been a 2-hour video, and I can't say that you wouldn't lose your attention span and want to move on to watching a different video, so I tried to shorten this up quite a bit, but kind of make it realistic as to what we might see in the future. And I almost hit the control tower there. So I've got about 3,500 hours of playing KSP over the years, and lately, I would say probably in the last 6 months or so, I stopped using the traditional landing gear and started using extendable hydraulic pistons with the grippy pads on them to make the landing gear more feasible, because you can tuck them inside of the fuel tanks as if they were extendable landing gear on an airplane. And here we are taking our Kerbals out one at a time. We've got the capacity for 11 Kerbal knots to come and go on this smaller ship to bring them to the base. You can see I've got a base station with some science modules on it, a big landing pad with a control tower and communications tower. You see the Starship landed next to us, and in the background there to the left a little bit, you can see the makeshift railgun that I created. And the reason that I created that is because I think in the future, once we've got quite an establishment on the moon, and if nuclear fusion power ever does come to fruition and we're mining helium-3 from the lunar regolith, we could very easily create a railgun. And the way I would design it would be much like the new generation aircraft carriers. Currently they're having a real big problem with the magnetic railguns, but they'll work through it soon enough and it'll be up and operating. I think the way I would design a railgun for the moon is to have some sort of pressurized tank for the helium-3, maybe a carbon fiber wrap sort of tank, although that's expensive to make. But nonetheless, it's very light, and you can mount that to a carrier harness with some reaction control systems or reaction control wheels. And you'd run this thing down this long track, and then you would increase the pitch so that it was moving upward, maybe 10 degrees or so, and detach it. And as the cart drives over the hump, the small spacecraft, or the tank of helium-3, which would have a small rocket motor on it, would lift off of the carrier harness, or the cart for the railgun, and then the railgun would have plenty of track to slow it down. Then it would basically rewind and pull that cart back to the beginning place for the next one. But you could basically develop a bunch of reusable rocket systems that attach to the cargo tank for the helium-3, and once you get it up into a circular orbit, you could maybe rendezvous with a Starship and fill up the cargo hold, and then the rocket motor that you attach to the helium-3 tank could then detach and return to the lunar surface, much like SpaceX's Falcon 9 system is working now, and therefore you'd have a completely reusable system. Granted, it would rely heavily on electricity, so you'd have to solve that problem, but you could send very large cargo tanks up into a circular orbit to be collected and then brought back to Earth in a very cheap way. One of the major things that allows this, if you ask me, is the fact that you're operating in a vacuum, so you just don't have to deal with the wind resistance that you would have to overcome on Earth or maybe Mars in a thicker atmosphere. So it's definitely a viable option, and I'm sure that in the future, in one way or another, they will probably do it. Here we are coming back down from the rim of the Shackleton crater. I brought old Gilbert Kerman up there to do a time-lapse photography scene of 1 month being spent on the southern pole of the Shackleton crater of the moon. So you can see what it's like to live there for a month, and now he's on the way back to base, and we're going to load up a few astronauts and send them back home. And here we are. You can kind of see the rail gun as we approach the base. And we're going to start slowing down here. Whoa, whoa. Oh, looks like the Kraken struck. It's either the Kraken or it's old Jebediah Kerman. I managed to kill him within the first 10 minutes of playing this game after I bought it, so he tends to come haunt me now and then. Every once in a while you'll see a photobomb. So I had to bring a new short bus to come pick up my astronauts and bring them back to the space station, send them home to Earth. So here we are taking off, getting a little bit of altitude, and we're going to do a speed run over the lunar surface at a low altitude and accelerate so we can raise our apogee up to about 65 kilometers and then circularize, and it'll be the end of the mission. But in the meantime, we're going to do a little zero gravity mischief here. Well, looks like Jebediah is haunting me again. He's going to go for a spacewalk and do a lap around our lunar lander as we rocket across the lunar surface at about 438 meters per second. I wonder if he'll make it back in time to get in the spaceship. They certainly don't have enough speed right now to stay in orbit, and they're on a collision course with the lunar surface. Yeah, it looks like he's going to make it. The ghost of Jebediah, everybody. He's going to take a ride home with us. So thank you to everybody who watched the full video. I hope that it was a little bit informative from maybe a small different point of view of somebody who has a little bit of scientific knowledge on the subject. I don't think all of us can know everything, but we certainly can learn enough to fit into a little niche in the space community, especially everybody who plays Kerbal Space Program. And I, like you guys, am looking very forward to Kerbal 2, and hopefully we'll see you then with some interesting videos. Until then, fly safe.